Okay, so we're going to solve another differential equation with Laplace transforms. This time it's y double prime minus 4y prime plus 4y equals 0, y of 0 equals -2, y prime of 0 equals 3. And again, we're going to take the Laplace transform of both sides. We're going to split it up into three different Laplace transforms, and we're going to factor out the constants. So we get Laplace transform of y double prime minus 4 Laplace transform of y prime plus 4 Laplace transform of y equals Laplace transform of 0. And again, we're going to use these two Laplace transform formulas from our table of Laplace transforms for the Laplace transform of y prime and y double prime. So the Laplace transform of y double prime is going to be s squared Laplace transform of y minus s y of 0 minus y prime of 0. Then we've got minus 4 times s Laplace transform of y minus y of 0 plus 4 Laplace transform of y, and then we have 0 on the right side. So here we can plug in our initial values. So y of 0 equals -2. So that's -2. This one's -2. And everywhere we see a y prime of 0, we're going to plug in 3. So that one gets a 3. So this becomes s squared Laplace transform of y plus 2s minus 3. Here I've got minus 4s Laplace transform of y, and then this is plus 2, and then times -4, that'll be -8. Then plus 4 Laplace transform of y equals 0. So we're going to group our Laplace transform of y terms together. Everything else has got to go to the right side. So the -3 and the -8, that's -11. If I move it over, it's going to be plus 11. And then 2s, if I move it over, it's going to be minus 2s. And then I'm going to factor out the Laplace transform of y from what's left over. So I get s squared minus 4s plus 4. And then I solve for the Laplace transform of y. So I divide by this s squared minus 4s plus 4. So the denominator here, it's a perfect square, so it does factor. So we're going to use partial fractions. So it's s minus 2 squared. So in partial fractions, we're going to set this up as, -2s plus 11 over s minus 2 squared. That's going to be equal to a over s minus 2 plus b over s minus 2 squared. Right, so that's the setup for a squared linear term. So if you don't remember this, you just need to go back to your calculus 2 or whenever you learned partial fractions and kind of get familiar with the different forms that you have to use. So we're going to multiply both sides by s minus 2 squared. It cancels out on the left. One of the s minus 2's is going to cancel out with the first term, and then they both cancel out on the second term. So let's get rid of this parentheses. Let's distribute. And we're just going to compare coefficients here. So a must be equal to -2. And then I have negative 2a plus b has to be equal to 11. So let's just plug in a equals negative 2. So that'll make this positive 4 plus b equals 11. So b is equal to 11 minus 4 is 7. All right, so we're just going to plug those back in. So we're going to say that the Laplace transform of y is a over s minus 2 plus b over s minus 2 squared. So we can say the inverse Laplace transform of both sides will give us y on the left, and then this will be, let's factor out the constants here, negative 2 times the inverse Laplace transform of 1 over s minus 2 plus 7 times the inverse Laplace transform 1 over s minus 2 squared. So we're just going to go back to our table, and the 1 over s minus 2, that I need to use this one, the Laplace transform of e to the at. So the first one's going to be negative 2 e to the 2t. For the second one, so it's actually going to be a combo between these two. So it's 1 over s squared, but it's also, it's s minus a inside the square. So actually we're using this guy right here. So if our Laplace transform is shifted by a, then we just multiply the original function by e to the at. So the original function we could say is 1 over s squared, and then it's shifted by 2. So this is going to be e to the 2t, that does the shift, and then the inverse Laplace transform of 1 over s squared is t. So we just need to simplify that a little bit. Well, not simplify, but just make it look better. 7t e to the 2t. Right, so this was a double root problem, from back when you learned just second order equations. But when you're doing the inverse Laplace transform, you've got to take into account when the transform shifts. Right? All right, good luck.